Utility analysis. You know, there's been a lot of work done here. De Brew, von Neumann, Morgenstern, even starting with Jeremy Bentham. Consider, if you will, that maybe most people like a hamburger and a car, or for those of you so inclined, maybe a tofu burger and an EV. Now consider this. In going from no car or burger to 2 burgers, are you as happy going from 0 to 1 and increased as much happiness going from 1 to 2? I don't think most people would say yes. And it's not hard to convert from burgers and cars to money or wealth. Consider a gamble of maybe a certain $50 or an uncertain outcome of equal probability of 25 and 75 bucks. Here's a graphic. The vertical scale are the utiles, that's what they call them, or smiles if you like. And notice it rises at a decreasing rate. We're using an exponent function. It turns out to be pretty good. And look, we can take the expected utility and compare it to the utility of the certainty or its certainty equivalent. The certain non-gamble 50 bucks gives us about 6.3 utiles or smiles. 75 gives us 7.2. The 25 gives us 5.0. And the average of the two is 6.1. That's the expected utility. But notice it's less than the 6.3 of the certain 50 bucks. And now notice that the 6.1 expected utility kicks back a certainty equivalent of some $43.30, a discount, if you like, of $6.70, meaning you wouldn't pay as much to take the gamble. Now notice among the assiduous amongst you that the increase in the amount of the spread of the gamble increases the amount of discount at a increasing rate, and likewise the case for the amount of the discount. Well, that nonlinearity, a product of the well-behaved exponent function, still does not mean we cannot make relative comparisons. Here, having a comparison between $1,000 and $2,000 with discounts for the $1,000 of $200 and the $2,000 of $400, and they maintain their relative position. Here's a graphic of all the data, and you know, this is not lost on pop culture. It's actually one of the bases for the TV show Deal or No Deal.